Alrighty, guys, today we're going to be getting into more review content. We're going to be focusing today on angles and their measures. So again, just a little bit of housekeeping. If you are taking your notes by hand, make sure that you've got your name in the top left corner of your scrap sheet of paper and this title, okay? Because remember, you are turning in your notes every day. If you printed this off, you can just follow along like normal. Um, Either way works for me as long as you're taking thorough notes. Also, make sure that your calculator is off to the side so you're prepared to answer questions on your own. I know it's tempting for me to do the math since I'm taking the video, but please make sure to get in the habit of using yours as well. So, first of all, we're going to break our notes into this first section on analyzing an angle that's in standard position. An angle is in standard position if it starts from this positive x-axis. Okay, so all the angles that we start with this year, not until I guess vectors unit do we change it, but you're going to be starting from this positive x-axis. If you have a positive angle, it is going to go in a counterclockwise direction. This is a positive angle. The symbol that we use for angle is that theta value. Then, wherever it lands, let's say that our angle lands there, that is called the terminal side of the angle. Terminal just means end. So a positive angle goes counterclockwise. You can probably put two and two together. If you have a negative angle, like negative 315 degrees, you would start at the same spot and travel in a clockwise direction. That is a negative angle. So we'll be practicing more with that in this bottom section. There are two different ways that we can measure angles. Angles can either be measured in degrees or radians. When you're measuring in degrees, a full rotation means a full way around the unit circle, around the circle. That is 360 degrees. If you are dealing with radians, a full rotation is said to be 2 pi radians. On this little XY axis below, we are going to practice putting key measurements in degrees and radians on that unit circle. So, remember, we always start from this positive x-axis. We're going to start with degrees since you're more comfortable with degrees. If you start at this positive axis and go nowhere, that is 0 degrees. If you travel along in a counterclockwise positive direction and you hit that first y-axis, that, of course, is 90 degrees. If we continue along, the next important measurement is 180 degrees. As you can see, it's a straight line from where it started. That is 180 degrees. Keep on traveling around, and I'm really sorry that my green circle is not looking like a circle, but you'll get the picture. 180 plus another 90 degrees gives us this key angle of 270 degrees. The nice vocabulary word for these angles that land on the axis are, we can call them axis angles, and we can also call them quadrantal angles because they break the quadrants into pieces. Then if you keep on traveling around, and you make a full rotation, that 0 degrees location is the same as 360 degrees. If we are dealing with radians, this would be 0 radians. If we went all the way around, I'm going to try to make a better circle here, but it might not work. All the way around, a full rotation is also 2 pi radians. So if this is 2 pi radians, if you went halfway around the circle to where 180 degrees is, think about what 2 pi split in half is. Well, 2 divided by 2 will give us 1 pi. So we just call that location pi radians. If you go in between 0 and pi radians, if you travel up from 0 and make it to where 90 degrees is, that is pi over 2 radians. So we have 0, pi over 2, pi, as you can see, we're counting by a half. Then we get to 1.5 pi, but we don't write it as 1.5, we write it as 3 pi over 2 radians. And then 1.5 plus a half, we get to 2 pi radians. Now, folks, let's take it up a notch and talk about going in the reverse direction. So let's start at this 0 degrees and go backwards. So we're going to go back to degree mode. If we're going backwards, a full quadrant, that 270 degrees is also negative 90 degrees. Keep on traveling backwards. That 180 degrees is the same as negative 180 degrees. Keep on going and going. 90 degrees is the same as negative 270 degrees. And if you go backwards, a full rotation, that is also negative 360 degrees. We're going to try the same thing, but with radians now. So let me change pen colors here. If we start at that positive x-axis and go backwards in radians, a full quadrant, 3 pi over 2 is the same location as negative pi over 2. Keep on going backwards. If we go backwards half the circle, that pi is the same as negative pi. Pi over 2, if we go back another pi over 2 radians, would be the same thing as negative 3 pi over 2. And then if we make it all the way around backwards, a full rotation, that is the same thing as negative 2 pi. So those are some key quadrantal angles, key axis angles to keep in your brain, especially as we dig into the unit circle more. In these next couple problems off to the side, we're going to practice figuring out what quadrant the angle lies in. So we've talked about all these angles off to the left, but we haven't talked about quadrants. The quadrant names are just numbers. In between 0 and 90 degrees is quadrant 1. In between 90 and 180 degrees is quadrant 2. The next quadrant down is quadrant 3. And our last quadrant in between 270 degrees and 360 is quadrant 4. If we have 2 pi over 3 radians, you've really got to think fractionally here. Ignore the pi for a second. 2/3. You need to think to yourself, is 2/3 bigger or smaller than 1 whole? Hopefully you're thinking it is larger than 1 whole. Is it bigger or larger than 1/2? It is larger than 1/2. So 2 pi over 3 radians would land in quadrant 2. Negative pi over 6, again, ignore the pi if you need to, and just think negative 1/6. First of all, if we're going negative, we are going backwards on the unit circle, only 1/6 radian. Remember that 1 whole radian would be over here, so split that 1 whole into 6 pieces, and you would land in the 4th quadrant. 16 degrees. Go ahead and give that one a shot. Try to figure out what quadrant that would land in. Pause the screen if you need to. 16 degrees, as you can obviously tell, is a positive angle. So you're going to start at that positive x-axis and go up 16 degrees. It lands in the 1st quadrant. Negative 225 degrees. Think if you're counting backwards, we go negative 90, negative 180. We wouldn't make it all the way to negative 270. That angle would land in the 2nd quadrant. And last, if you haven't tried already, go ahead and pause if you haven't already and try 7 pi over 6. Try to figure out where that would land. Remember again, if the pi confuses you, just drop it off for a second and think about 7/6. 7/6 is bigger than 1. So if we're starting at the positive x-axis, 1 whole pi lands right there. 1 pi with a denominator of 6 is like 6 out of 6. So we have 6 out of 6 gets us here, and we only need to go 7 pi over 6, so 1/6 more. 7 pi over 6 would land you in the 3rd quadrant. Check to make sure that you have each of those quadrant locations correct. If you need to go over some more of those in our little office hours portion of class, please make sure that you're asking. Let's go on to the next page. In this next portion, we're going to practice drawing each angle. We're going to practice starting at the positive x-axis and landing in the appropriate quadrant. So we have ourselves 45 degrees. Remember, we're starting at the positive x-axis. And think about where 45 degrees lands in regards to those big quadrantal angles that we talked about on the page before. 45 degrees is right smack in between 0 and 90. So we can label this angle 45 degrees. Let's go over to a larger angle over here and think about negative 405 degrees. In your head, you might be thinking, well, 405, first of all, it's negative, so we're going to be going backwards on the unit circle, but you're probably also thinking that it is bigger than one full rotation. If that's the case, that means we're going around the circle more than once. If you want to figure out how much farther around the unit circle we're going, take away a full rotation from 405. 360 taken away from 405 gives us 45 degrees. So just like before, we'll start at this positive x-axis and we're going to travel backwards. So we go backwards 360 degrees. We need to go 45 degrees more. That will get us midway into the fourth quadrant. So that entire angle is negative 405 degrees. The last one we're going to look at here is 16 pi over 3. Obviously, we're dealing with radians, and you're hopefully are thinking, well, 16 thirds is a lot bigger than 2. If you put 3 into 16, it's going to go more than 2 times, which means that this, kind of like the problem before that we were dealing with, is going to go around the circle more than once. Just like before, we're going to take 16 pi over 3, and we're going to subtract a full rotation. Since it's radians, we're going to subtract 2 pi. So we're going to do 16 pi over 3. If we want to subtract those, we need to have a common denominator. 2 pi is the same thing as 6 pi over 3. Those are synonymous to each other. 16 minus 6 is 10 pi over 3. This still is larger than a full rotation. 3 goes into 10 more than 2 times. So we need to take 10 pi over 3 and subtract 2 pi, or take 10 pi over 3 and subtract 6 pi over 3. We would then get 4 pi over 3. 4 thirds is in between 0 and 2 pi, so we're good to go there. Don't forget that each time that we subtracted 2 pi, that is a full rotation around the circle. So when we start drawing this, we start at the x-axis. We're going to go around once. We're going to go around twice. That gets us to 2 rotations around, and then we need to go 4 pi over 3 farther. 4 thirds is 1 third larger than 1 full pi, so we land in quadrant 3. If that was confusing to you, I'm going to teach you a way in just a minute to change that 16 pi over 3 into degrees and deal with it in degrees if radians are confusing to you. In this next portion, we're going to practice converting in between those 2 units of degrees and radians. If you want to convert from degrees to radians, you're going to take the entire fraction and you're going to multiply by pi over 180. On the other hand, if you want to go from radians, something that has pi, into degrees, you're going to multiply by 180 over pi. I'm going to highlight these. I would encourage you to as well. Those are going to be helpful little formulas to get you through some math problems in the future. So let's zoom into this first one, 275 degrees. We're going to practice changing that from degrees to radians. So we're going to take 275 degrees and multiply it by pi over 180. You can imagine that this 275 is over 1, multiply straight across. So we have 275 pi over 180. Now, that, of course, is not a reduced fraction. If you want to reduce it in your calculator, make sure that you're doing 275 divided by 180, and your calculator, if you have a graphing calculator, will change that to a fraction by pushing math, the math button, frac, which is just number 1, enter. So it's just math, enter, enter. So again, you're not plugging the pi into your calculator. You're just plugging in 275 over 180, math, enter, enter. If you do that, you should hopefully get 55 pi over 36. Look at the problem to the right. We have negative 11 pi over 6. We want to change that to radians. Sorry, from radians to degrees. So we have negative 11 pi over 6. To change it into degrees, we're going to use that equation in the top right. We'll multiply it by 180 over pi. Now, you should notice that these pi's, you have a numerator, pi in the numerator and the pi in the denominator, those will cancel out, and you'll multiply straight across. So you have negative 11 times 180 divided by 6. Simplify that using your calculator, and you should get negative 330 degrees. Make sure that you put that degrees on your answer. I want you to pause the screen and you try out these two. Try changing 7 pi over 2 into degrees and try changing 70 degrees into radians. 7 pi over 2, you should have converted to 630 degrees. 70 degrees, you should have converted to 7 pi over 18. Going back to that problem that we had just completed beforehand, if you wanted to look at 16 pi over 3 and draw it on the coordinate plane, and the radians confused you, you can always take 16 pi over 3 and change it into degrees, which is probably a format that you're more comfortable with. Change it to degrees by multiplying it by 180 over pi. The pi's will cancel. You'll multiply straight across, 16 times 180 divided by 3, and you get 960 degrees. Then you can keep subtracting 360 to see how many times you need to go around the circle and see what is left over. So that's another way to take that 16 pi over 3 and map it out on the unit circle. In this last portion here, we're going to be talking about this vocabulary word called coterminal angles. Coterminal angles are simply angles that have the same initial and terminal side, meaning they have the same starting and ending point. So what are they? They're angles with the same initial and terminal side, meaning they have the same start and the same end. To find a positive coterminal angle, well, let me give you an example real quick. Let's say we have this angle 60 degrees. 60 degrees has a coterminal angle that starts at the same location and goes backwards. 60 degrees and negative 300 are coterminal angles. They have the same starting point and the same ending point. To find a positive coterminal angle, you will add a full rotation, meaning you will either add 360 degrees if we're dealing with degrees, or if we're dealing with radians, you'll add 2 pi. To find a negative coterminal angle, you will simply subtract a full rotation. So you will either subtract 360 degrees or subtract 2 pi, depending upon what the problem gives you to begin with. You can find innumerable coterminal angles. You could go on for years and years just writing coterminal angles. But in this problem, we're going to find 2 positive coterminal angles with 75 degrees. So to find the first one, we'll take 75 degrees, add 360 degrees. 435 degrees has the same beginning and end point as 75 degrees. Take that same angle, add 360 degrees, and we can find another coterminal angle. 795 degrees is another positive coterminal angle. Let's do the same thing, except in this next problem, we're going to find two negative coterminal angles of 2 pi over 3. So we're going to take 2 pi over 3, and we're going to subtract a full rotation. We're going to subtract 2 pi. Remember, to subtract fractions, you have to have common denominators. So 2 pi over 3 minus 6 pi over 3 is the same thing as 2 pi, just with a denominator of 3. 2 minus 6 gives us negative 4 pi over 3. That has the same starting and ending point as 2 pi over 3. Take that same angle and subtract 2 pi again. Negative 4 minus 6 gives us negative 10 pi over 3. If you're not comfortable doing that by hand, you can also take 2/3 in your calculator and subtract 2. Make sure that you're changing it back to a fraction by pushing math, enter, enter. When we're dealing with radians, we don't ever use decimals. And you should get negative 4 pi over 3. Take negative 4/3, subtract 2 again, and you get negative 10 pi over 3. You'll get to practice that in your homework assignment today. Remember, if you have questions about any of these problems, log in at the end of class so you can ask some questions before starting your assignment. Proud of you guys. Keep working hard.